You what? I was just asking how you were doing. I didn't say it had to be done tonight.
Okay, I do have a question.
Yes.
So on like the outputs for, hold on, I pulled up that words.
Text filtering?
The cluster and the text.
Yes.
So it's like in the assignment you say like, oh, describe them, but there's like a ton of them. So
describe some of them.
Okay. So just pick out a couple key ones.
Pick out a few ones that are actually making sense.
Okay.
Describe them.
Okay.
Yes, if you decide to have 50 clusters, I do not need 50 clusters described.
Okay, cool.
However, feel free to mess with the number of clusters and decide, do you want 50? Do you want 20? Right? Try to find some clusters that actually make sense that you think you might actually use. You may want a lot. You may not want very much. You may want a lot of clusters. You may just want a few topics. Okay? Think about your ultimate goal and what you're trying to classify. If you were the human, oh wait, you are the human. You being the human, how would you want this data to be classified? And can you make the computer do that? So think about the data that you have, Amazon, IMDb, Yelp. Think about your positive, negative, neutral comments, whatever. How would you have personally tried to sort this, try to cluster it, and then see if you can make the software do what you want to do. That was one thing, just kind of showing you an idea of structured versus unstructured data. Another thing you guys seem to be asking all about is this idea. So, we're going to get to see how well the AMPS models work, because I actually have new data for them. And they're going to get to apply this. For you all, you get to kind of apply it. So what I have up here, and this is going to answer the previous question, right? So what? We have this neural network model. I got nothing, right? I can't make a formula. I don't have rules to explain it. Yay, it's our best model! Right? So what's going to happen? All of this should look very familiar. We started with our, yes, I'm back to churn. This was our original, we hated it, churn data set. In our churn data, I explored, I graphed it, figured out that the churn, reminding ourselves, was 15% of our customers churn and 85% of our customers didn't churn. So if I can't come up with a model that beats 15%, then I don't need to worry about it. I partitioned my data. I did the defaults for regression to KNN, a decision tree, and a neural network. I compared my models. And that, so far this semester, is the one where we've stopped. So what we're going to add in is I'm going to add in some new data. And I'm going to do this thing called scoring. And what's happening with the scoring is we're actually going to take the best model from here. We're going to have new data. And this new data is going to be without a target. And then we're going to score it, and we're going to find out the prediction. So all this stuff at the beginning, that's what we've been working on all semester long. Now we're going to do this. Yeah.
So if you don't have your target, how do you know, like, how well you do right or wrong?
You don't.
All right. It's a mystery.
You don't know how well it worked.
You just go for it.
You just got to go for it.
Okay.
Right? So this is why we have our training data and our validation data. Is we're pretty sure we know how good this model is going to be, and then we got to take action.
And you just have to go through it.
Then we just got to do it. We just got to do it. So we're going to take action. We're going to say, okay, here's 10 new customers. Are we going to predict that they're going to churn or not churn? And the ones that are going to churn, we'll go do something with them. And the ones that we predict aren't going to churn, we're going to let it go. I'm going to show one more slide. And then I'm actually going to go into EM and show you how to do it. And then we'll review for our test. The other thing we're going to consider, right, because we're familiar with our churn data set. So with our churn data set, like I said, 15% churn 85% don't. Okay? So 15% churn, 85% don't. When we did this in the past for your linear and your logistic regression, I guess in this case your logistic regression, you're trying to predict churn, you're like, it doesn't work. It's still predicting it's basically your model was predicting everybody was going to churn. Or sorry, everybody was going to stay with the company. Right? That's what our model said. The model says everybody's going to stay with the company. So we threw out the idea, was it the data, because there was so many customers who didn't churn, that we couldn't get a model to actually really predict if you were going to churn or not churn. So one of the things that we can do here is we can actually do the oversampling idea. Okay. So what if I didn't have 85% 15? What if I had closer to a 50-50 split? Then could my model actually determine who's going to stay and who's going to churn?
So that's better to have that, like the 50-50 split.
There's a question. So this is a way to, so really doing both is probably the best. Right, so I do the initial modeling, and if I can do the initial modeling and everything comes out well, then I'm okay. We did the initial modeling on our churn data set, and it was coming up with, you know what, just say everybody's going to stay. We couldn't find a model that was doing better than just saying that everybody's going to stay. So to decide, well, is it us and our model creation, or is it just the function of the data? Now we can do this idea. So what I've done, and again, I'll show you this in stats in a second, I've actually filtered the data set. So I've taken my entire, so this is the whole thing. Here I filter it. This is where the customers are all false, so they stay. Here's the ones that leave. Well, the ones that leave, this is my 15% here. I want to keep all of those. I need them. Here, I've got 85%. That's too much. So my leave, this is about 460 people. This is about, I don't know, I'm rounding a little bit, about 2,800 people. I want those similar. I want those to be similar. So I'm going to sample, I want to have a new stay that has about 500 people in it. So now I'm going to have 500 people stay, 460 people leave. This is where we're going to append, not merge. I told some of you guys to merge. Merge doesn't work as well. Okay, did you hear that?
Yeah.
You're like, yeah, Dr. Kiefer. We're going to append, so we're going to stack these two things on top of each other. We're going to put it all back into one data set. We're going to drop some extra variables, because when we have these variables, this is going to say sample 1, like this is sample 1, this is sample 2. So we're going to have to drop the category that says sample 1, sample 2. Because if not, that's going to be a perfect predictor. Everybody in sample 1 is going to stay, or everybody in sample 1 is going to leave, and everybody in sample 2 is going to stay. Like, that's the way we created it. So we need to actually drop that variable to be able to predict. Okay. So that's what's going to happen. That was the front half. I'm going to attach it to the data partition. I'm going to run my 4 models. I'll have my model comparison. I'll find the best model. I'll score the data, and I'll see what happens. Ready to see how this works? All right. In your learning module, in module 12 and 13, at the very bottom, you will find I have a churn dirty data set, I have a churn clean data set, and I have a churn score data set. So you have to have its own data set for scoring. It has to look exactly like the clean data set that we use. Okay, because we're going to be pulling off the same variables. It's got to look exactly like it. It's going to match up exactly. The only thing that's going to be different is, there you go, score data set. The only thing that's going to be different is our churn column is blank. So what we have here is I've got 10 customers, and I randomly selected them because I could. So I picked 10 customers. These are 10 new customers, and I want to find out, are they going to churn or are they going to stay? We're going to classify, we're going to predict. So if I go into SAS Enterprise Miner, because I wasn't sure how much time we had, I already have this created. So I'll show you the highlights. And then you can recreate it, and if you have questions, we can talk about it next week. Or stop by my office hour. So things we already know how to do: import data, look at data, partition data, run the different models, model comparison. So at the end, everybody's okay with this one. You're like, yeah, we just did this. So at the end, what we find out is our validation misclassification rate, they're all predicting right at that 15%, which is exactly what we would expect. We went and looked. So, true positives, none. We're not getting any of those. We're not getting it right anywhere. There's a couple of false positives of the neural network, but really, none. Okay? So this is what's happening. We got all the true negatives correct, and then we got these that are false negatives. So somebody was asking earlier, is it possible to get zeros? Yes. Okay. Basically, go ahead.
No, I think it's pretty simple.
Yeah, so what our model is doing is it's just classifying everybody as safe. That's what our model's doing. And I'm getting it right a lot, and when I miss it, I'm missing it by classifying and saying, you're staying. That's what the false negatives do. That's fine. That's how the model's working. We're like, yeah, can we get a better model? So if I was to, and so what I have to do, so I import a new data set. Just like I did before, I brought down my file import, pull the data in. The thing that changes is when you're trying to import this data, the role down here, the default is train, and that's what it's been this entire semester because that's all we needed it to be. But you have to change it to score. Okay? You have to let it know that it's a scoring data set because then it's going to be like, oh, okay. So even though you're going to tell me there's a target variable, there's going to be an empty missing column, and that's okay. I know I'm supposed to fill that in. Okay? So we set up the data exactly like we did before. We pull down this score node. So the score node is over here on the assess. We have a score node. Pull it right down. No settings, nothing you have to change. Life is good. You run this model. And then at the end of this model, you can actually, the results don't make a lot of sense, but you can actually go to the exported data. And we want to go down here, like, so far we've been doing either the train or the validation. Now we want this score data set. We're going to export it. And as we explore, there's a whole bunch of information that we have. If we go all the way to the end, this is the prediction one. And we predicted that everybody was going to be false. Everybody stayed. And that's what happened, right? So I started out with a data set that didn't have anything, that the churn was blank, had all the information about it, but we didn't know if they were going to churn or not. I put it into the model that I created, knowing that the model I created said everybody was going to churn. And when it came out the other end, surprise, surprise, it said all 10 of these people are not going to churn. Yes.
So assuming those two columns next to it is like probability true and probability false. So it appears to be really confident that turn around.
Yep. So that's the probability level for true and the probability level for false.
Which I guess is pretty cool that it gives, just because even though it's saying everyone will churn,
most likely you're not going to believe that, but you can still come and say, you know, let's pull all the records that have a probability of true higher than 30%.
Absolutely, right?
And still, you know, try to do it for people.
Absolutely.
Or if you had a good model, it would be interesting to see, like, how confident is it
Right.
in each decision it's making.
So when we have a good model, so there comes the next question. Can we create a good model? And so finding out if we can create a good model or not, I come down to my second point. So I open up, I bring in my first set of data, and then I'm going to filter. And you can find the filter over here on the sample. So when you sample, you can filter, and you bring the filter down. And for the filtering, the easiest way that I found to do it is because we're going to be filtering on a class variable. Did somebody churn or did they not? Right, so this is our original data set. We do have churn and not churn in here. So I'm going to go down to the class variable. I'm going to hit the little ellipse right here. And that's area code. Well, I don't actually want area code. That's crazy. I want churn. Churn. I like churn. So you can actually look at churn. You can decide, and it says select the values to remove from the sample. Right? So I named this node false. Okay? So this is going to be everyone who does not churn. False, does not churn. So I want to remove everyone who does churn. So I'm going to select true. Not going to lie, last night when I was doing this, I had it backwards in my head and things were not working out well. Right, so select the values you want to remove. So here I removed all the true ones. Down here where it's true, if you go in and look, I removed all the false churns. Okay. So what I've done at this point, this is a group of the 2,800 that they're staying with the company, they're not churning, false churn. Down here is the people who are leaving the company who have a true churn, about 460. So the 460, I want to keep all those. Here's the 480, or the 2,800. I only want a sample of those. So I bring down my sampling nodes. My sampling node can be found also in the sample tab. Let me bring it down. And here, you actually get to choose. Do you want the number of observations? And you guys played with the sampling node with the Dillard's data set, I think. A lot of you did. Right? Do you want a percentage? Do you just want to say how many values you want? I did number of observations, and I just said I want 500. I could have said I wanted 10%, but I just said, I know, I've already done the math. I know I want about 500. So I sample it there. The append really is just you connect the ones you want to append, and it snaps them together, one on top of the other. Again, this works the best when all of the column names are exactly the same. Once we hit the append, real quick, we'll look at the exported data. I'm going to look at, in this case, I'm still looking at just the training data set. We haven't done anything with it. And what you'll see is that now I have churn, and I have churn that's true for a whole bunch, and I have churn that's false. I have 961 rows, so that's the 500 plus the 460, 461. So I have some information that I can use. So they're just appended, just connected together. Looking at this data set, I have this NODE, so it's node ID. And this node ID, here's my filter 2. Where's my falses? And for my false, I have a sample. So when I try to decide, can you classify who's going to be churn or not churn? It's like, yeah, I can do it perfectly. If they were in the sample, they're not going to churn. And if they were in the other one, they are going to churn. And I actually did that the first time. I'm like, this is awesome. Except it wasn't. Okay? So that's where the drop feature comes in. We're going to go in and we're actually going to drop, if you edit the variables. So you can tell me that I'm going to drop this node ID. So now, sample 1 versus sample, that part's not going to be there. And then just like you would before. So now we've got the data how we want it. We partition the data. we do the regression, we have a model comparison, and now we can see, yes, is this going to work? Now that we have a good 50-50 representation, look how great that model is. Can you see how great it is? It ranges from a misclassification rate of 45% to 50%. I'm so excited. So basically, what can I do with the customer that walks in the door?
Flip a coin.
Flip a coin. Okay, so our model doesn't do good. None of the models do good. But now I actually have a model. Even though it's not great, it still actually will work. So I'm going to bring in that exact same data set. I set it all up, get it on a match. And if I score it, and we look at the exported data from the score node, right, I've got 10 new clients. Looking at the score data. Roll all the way to the right. The predictions are actually there. True, true, false, true, false, true, true, false. It made predictions.
Look what it did to all the probabilities. So it's all
That's 50-50, right? So yeah, it's true, yeah, it's false, it's true, right? Those probabilities are so much more close. But it worked. And so this is where, so no, it doesn't always come back false, it doesn't always come back true. It's what's in the middle.
Do you have the list for the model comparison? Is it all about one or just under one?
I didn't go in and look at all of them. You can go see. It shouldn't be hard to do at all. So this is what you can do. So to answer the question of the neural network, no, you can't say, here's my neural network. But if I give you new data, you can run it through the neural network model now, and you can find out how you would predict. Scoring, oversampling, yes.
So the score, can you open an Excel file of score?
Yes.
So that still has the ID, right? But in our model, you already dropped the ID. So would there not be a problem in your?
No, it wouldn't matter. No, because I dropped the ID. Because the ID is just a random variable. It's just a naming convention. So I don't need the ID.
So I mean, again, in this also you have to make sure you drop the ID, right, before
Yes.
you run it.
Yes.
So the number, the column should be exactly the same as it is in the.
Yes. Yeah. So what we didn't do, what I didn't actually show you was when I edited the variables, I made sure to change area code to nominal. I changed target to churn. I rejected the phone and the state, and the ID was still right. So it's good. But yeah, so the model, so it needs to, the score data and the original data need to be set up with the exact same columns. You need to reject, you need to change intervals, they need to look exactly the same. The only thing difference is just the score data doesn't have the value. Yes?
For the score, so is it running the data through every model or just the best?
Just the best one.
How is it determined? Is that just one error metric?
So
Misclassification?
here it's looking just below its classification. So it says that it picked the regression model. So it's going to run it through the regression model.
What I'm asking, another question, like some of our presentations, they wanted to minimize like a certain false positive or something. Is it possible to do that, or would you just have to do that on your own?
Then you do it on your own. Right, so the model comparison says use the regression model. I'm like, yeah, but I really want to use the decision tree. So I would just ditch the model comparison node, and I would put the decision tree going to the score node, and then it would run off the decision tree. Alright. So just a quick insight into oversampling and scoring. We've got about 20 minutes of class left. The last thing we have would